Alright, good morning everyone. Welcome for today's tutorial. Today we are going to look at basic mathematics, and under this basic mathematics we are going to look at indices. So let's go deep into this topic for us today. We have basic mathematics. Indices. Now, as you look at the word indices, what do you understand by indices? Indices is letting us know a number that is multiplicable in an expression is based on the multiplication of a number. How many times a number can be multiplied with respect to the power. That is what indices is all about. Indices is also known as the index of a number, or the exponent of a number, or the power of a number. For example, if we have 2 raised to the power of 3. 2 raised to the power of 3 is a form of indices, because the power 3 is telling us how many times 2 can be multiplied by itself. So that is what indices is all about. And in this case, the 2 here, where 2 is the base. 2, this 2 is called the base, and 3 is called the power, or the index, or the exponent. 2 is called the base, and then 3, which is the power, is called the power or the index, or you can also call it the exponent. So when you hear about the exponent, you know that they are talking about the power. If you hear about the index, you know that they are talking about the power. If you hear about power, they are also talking about what? This index. So that is what indices is all about. Now when we look at indices, we have type of indices. And how can we identify this type of indices? Number one, we have positive index. Positive what? Index. Positive index example, you have 5 raised to the power of what? 2. 5 raised to the power of 2 is a type of indices which is called what? Positive index. Why? Because the power is what? Raised to a positive number. The power is in the form of what? Positive what? Number. So this is called what? Positive index of indices. Also, if you have 3 raised to the power of 2, it's also an example of what? Positive index, because the power that is raised to the base is in positive what? Form. So that is what positive index is all about. Now we have the second type of index called the word negative index. The negative word? The negative index. The negative index of indices is letting us know that the base is raised to a negative number, a negative power. For example, 3 raised to the power of what? Minus 2. This is a negative word? Index. Because the power that is raised to this 3 is in what? Negative form. Also, if you have 2 raised to the power of what? Negative 3, it's also an example of negative word? Index. I've also expressed this guy. That is, if we want to express 2 raised to the power of minus 2, since it's a negative index, you know that by this guy, this implies that we are going to have what? 1. This minus is going to turn as what? 1. Then this 2 will fall down upon what? The word 3. Which is what? 1 raised to the power of what? 3. 1 all over what? 3 raised to the power of 2. Because this minus turns to what? 1. And then we have 3 now, the 2 now fall upon the word 3, which is this power 2. And we know that we are going to have 1 all over what? 9. Because 3 raised to the power of 2 is what? 9. So this is how to express negative index of indices. Now let's look at the third type of indices. The third type of indices. The third type of indices, we have the zero index. Zero what? Index. The zero index is letting us know that the power is raised to what? The base is raised to power 0. That is all what it means. So if you have something like 5 raised to the power of what? 0, it's an example of the type of index called what? Zero index. Because the power is raised to what? Power 0. And by law of indices, everything raised to the power of 0 is what? Is equals to 1. So that is it. Now if you can also have 3 raised to the power of what? 0 is a zero index. And by law of indices, anything to the power of 0 is what? 1. So this kind of indices is called what? Zero what? Index, because the power is raised to what? Power of what? 0. Now let's look at the fourth type of indices. The fourth type of indices, we have what they call fractional index. The fractional index, the fractional index. The fractional index is letting us know that the base is raised to a fraction. So, for example, we have 4 raised to the power of what? 3 all over 2. This kind of indices is called a fractional index because the base, which is 4, is raised to the power of what? Of a fraction. So, in this case, this kind of indices is called what? Fractional index. You can also have something like 3 raised to the power of what? 1 all over 2. It is also a fractional what? Index. Because the base is raised to what? A fraction. So this kind of indices is called what? Fractional index. Now we have already seen and considered the type of indices. Let's go down into the law of indices. Alright, now we're going to look at the law of indices and how to solve them using what? Some example. Now as you look at law of indices, number 1, we have what they call multiplication what? Law of indices. Multiplication law. We have multiplication law. Multiplication law of indices. If we have a base raised to the power of what? M times that same base A raised to the power of what? N. By the law of indices, the law said that since they have the same base, which is what? A and A, that we should take only one of the base, since they are what? The same, take only one of the base and then add their power together, which is what? M times plus what? N. This is called the multiplication law of indices. This law is applied when we have a base that is in the same word form. When we have a base that are the same numbers, this is when we apply multiplication law of what? Indices. Let's look at an example on it. Example 1. We have 2 raised to the power of 3 times 2 raised to the power of what? 1. They say you should express this guy. Now if you look at this question, we have the first question, the base raised to the power 3, right? And the second one, the expression, the base is raised to the power of 1. Now by the law of multiplication of indices, the law let us know that since they have the same base, which is what? Base 2 and what? Base 2. Since they have the same base, we are going to take only one of the base, which is 2. And then we add their power together. So we're going to have 2, then 3 plus what? 1. Now at this point in time, 3 plus 1, you have known that I'm still going to have what? 2 raised to the power 3 plus 1 is what? 4. Now by expression, look at by expression, you are going to have what? This is going to become what? 2 times 2 times 2 times 2. Now if you look at this, is letting us know that the 2 is multiplied itself by what? 4 times. So 2 times 2 is what? 4. 4 times 2 is what? 8, right? 8 times 2 is what? 16. So therefore, the final answer is what? 16. And this is called what? A multiplication law of what? Indices. Now look at example 2. Example 2, they say we should express this guy. We have 5 raised to the power of 3 times 5 raised to the power of 2. Now for us to be able to express this guy, we know that this is multiply what? Themselves, right? We have first expression multiplied with what? Second expression. And from the law of multiplication of indices, you know that when two bases which are in the same form multiply themselves, their power, even though they are different, their power will be what? Added. So if you look at this question, from this question you know that we have base of what? 5, right? And the second one we also have what? Base of 5. So since they are in the same base, we take only one of the base by the law of indices, which is base 5, right? Then their power now will be added. The first one, the power was what? 3, right? Then plus the second one, the power was what? 2. So we are going to have our 5 raised to the power of what? 3 plus 2. 3 plus 2 is what? 5, right? Then you can just express this guy 5 times 5 times 5 times 5 times 5. That is 5 times, right? 5 times 5 going to give us what? 25, right? Now 25 times 5. 25 times 5 going to give us what? This is 25. This is what? 10. 125. Then times 5. This what? 25, right? Times 10. This is what? 10, 12. Times this 5. Times 5. Times 5 again. 5 times 5 is what? 25. 5 times 2 is what? 10, right? Plus 5. That is 15. 5 times 5 is what? 25. Plus 1. That is what? 655. So this will be our final answer when expressing this word gang. Now let's move on to the other law of what? Multiplication. Let's move on to other law of indices rather. Now we have the second law of indices. The second law of indices we have here, we have what they call zero what? Law. Zero law of indices letting us know that anything raised to the power of 0 is 0, except 0 itself. If you have 5 raised to the power of 0 is what? 1. Because anything raised to the power of 0 is what? 1. Or if you also have 100 raised to the power of 0, it's the same thing as what? 1. Except you have 0 raised to the power of 0. This is not equal to what? 1. This is what? 0 raised to the power of 0 is what? 0. Any other numbers that is raised to the power of 0 by the law of indices of 0 law is 1. Except 0 itself that is not equal to 1. Now let's look at how to express another law of indices. The third law of indices we are going to look at is called power law. The third law is what? Power what? Power law. By power law of indices, if you have a base raised to power y, and that power is multiplied by another power, let me say x. By power law of indices, the power law of indices is letting us know that the power multiply what? Themselves. So we are going to have a raised to the power of what? X and what? Y. But x times y is what? Xy. So this is the formula for what? Power law of indices. Let's look at example on it. Let's look at example on it. If you have 2 raised to the power of 3 multiplied by another power of 2. This is 2. Now by power law in indices, the power is going to multiply themselves. We are going to use the power to multiply the power inside, on top of the base, right? So we are going to have, this is going to be what? 2, right? Then 3 times what? 3 times 2. So we are going to have the base 2. 3 times 2 is what? Is 6, right? Now we are having 6. 2 raised to the power of what? 6. At this point in time, we are going to look at 2 raised to the power of 6 is what? We are going to have 2 times 2 times 2 times 2 times 2 times 2. This is letting us know that we should count these 2. 2 is multiplied itself by what? 6 times. So we have 1, 2, 3, 4, 5, 6. 2 times 2 is what? 4, right? 4 times 2 is what? 8. 8 times 2 is what? 16, right? 16 times 2 is what? 32. 32 times 2 is what? This is what? 64. And this is our final answer. This is how to apply power law when solving indices. Now let's look at the second example on this power law when solving indices. Example 2. We have 3 raised to the power of 2 times 2. Now by the power law, I let us know that the power will multiply themselves, right? Then we take only one, the base that we have here. So this is going to be what? 3 raised to the power of 2 times 2. And then we're going to have 3 raised to the power of 2 is what? 2 times 2 is what? 4, right? So this is letting us know that 3 is raised to the power of what? 4. And for us to express it, you can use your calculator and just get it through your calculator. But if you want to express it in a form that you want to also understand, is 3 times 3 times 3 times 3. Because 3 raised to the power of 4, it letting us know that 3 is multiplied itself 4 times. That's why I express in this one. 3 times 3 times 3 times 3. 3 times 3 is what? 9, right? 9 times 3 is what? 27, right? 27 times 3 is what? Which is what? 81. And this is the final answer. Now we are talking about power law in indices. Now let's look at other law in indices and how to solve them using example. Number 4, we have power of a product. We are looking at now a law of indices, which is called power of a product. We apply a power of a product when we have put something in the expression like this. Is we have 2 functions or 2 numbers multiply themselves and they are raised to power n. Let me just say they are raised to power n. Know that in this case the power is going to affect everything in the bracket. So this is going to be what? A raised to power of what? N, right? And then b also raised to the power of what? N. Because the power is affecting everything in the what? The bracket. Now at this point in time, look at example. Now if you have in a bracket 2 times 3 raised to the power of 2. By power of a product law, this is letting us know that the power 2 is affecting everything in the bracket. So we're going to have the expression 2 raised to the power of what? 2 times, because this power is affecting this 2 and it's also affecting this 3 times which one? The 3, right? Raised to the power of what? 2. Now by expression, you know that we're going to have 2 raised to the power of 2 is the same thing as what? 2 multiplied itself what? 2 times. This is 2 times 2, right? Then times this times here. 3 raised to the power of 2 is telling us that 3 multiplied itself what? How many times? 2 times. This is what? 3 times 3. 2 times 2 is what? 4. Times this times here. 3 times 3 is what? 9, right? Now if you look at 4 times 9 is what? 36. And this is the what? Answer using what? Power of a product law in indices. Now at this point in time, if you can also express this guy in another form, which is also simplest when expressing it. If you have something like bracket 2 times 3 raised to the power of what? 2. If you want to use shortcut, you can just say 2 times 3 will give us what? 6, right? And we know it's raised to the power of what? 2. Now this guy is raised to the power of 2. It's letting us know that 6 raised to the power of 2 is the same thing as what? 6 multiplied itself 2 times, right? And we know that 6 times 6 is the same thing as what? 36. This is another method of solving this kind of question. But by power law, I will let you know, by power of a product law, I'll apply that you need to apply this first one when solving this kind of question. Now let's look at another law in indices before we move on to the next thing we have. Alright. Number 5, we have what they call division law. Division law of indices. Division law of indices, we apply division law of indices when we have a base raised to power x all over that same base raised to power of what? Y. By division law, this is going to be what? The first one, which is what? A raised to the power of x. We're going to subtract. It's going to be what? Subtract from the power of the second one. We just take only one of the base. Since they are in the same what? Base. We take only one of the base, which is a, and then subtract their power, which is what? X minus what? Y. Their power we are subtracting is, we subtract the first one from the down one. Don't make mistake and subtract the down one from the first one. If not, you get a wrong answer. So, how to solve this kind of question? See, they have the same base. A raised to the power of x and all over a raised to the power of y. For us to solve this kind of question, we take only one of the base, which is what? A. Because they have the same base in common, we take only that base, one of the base. Then we subtract the first one on top, the denominator, the power of the denominator, from the power of the denominator. I hope you understand. Okay, now let's look at example on how to solve it. Example 1. We have 2 raised to the power of 4 all over 2 raised to the power of 3. They say you should express this guy, express it. Once we want to express this guy, you know that we are going to apply it using what? Division law. Because we have 2 indices or index dividing what? Themselves. So at this point in time, you know that they have thing in common, right? Which is what? The same base, which is base 2 raised to the power of 4, and this is base 2 raised to the power of 3. Since they have the same base, by law of what? Division, we take only the one of the base, which is what? 2. And now at this point in time, we subtract the base, the first base, the first power of the first base, which is what? 4, from what? The second, the downside, which is what? Minus 3. We subtract their power, and the power, how we are subtracting it, we subtract the power of the up one from the down one. Now at this point, we're going to have what? 2 raised to the power of 4 minus 3 is what? 1, right? And this guy is letting us know that 2 raised to the power of 1 by law of indices. Anything raised to the power of 1 is what? The same thing as that number, which is equal to what? Equals to 2. And this is the final answer when solving this kind of question. Now let's look at example 2. Example 2, they gave us 8 x 8s raised to the power of 2 times y raised to the power of 3 all over 4 x raised to the power of 4x times what? Y raised to the power of 2. They say we should explain this kind of question. This form is also use indices to solve this kind of question. Now if you look at the first one, we have 8 raised to the power of what? X raised to the power of 2. Y raised to the power of what? 3. Now if you look at this downside, we have x and then y raised to the power of what? 2. Now let's explain this guy well. Solution. We have what? 8 x raised to the power of what? 2, right? 8 x raised to the power of 2. This is power, please. This is power x and what? Y squared. 8 x raised to the power of 2 and then y raised to the power of 3 all over what? 4x y raised to the power of 2. Now let's explain this guy very well. You know that this guy is the same thing as what? If you look at this guy, it's the same thing as 4 divided by 8 divided by 4 is what? 2, right? We are having what? 2. Now we subtract their base. We subtract their base. I'm going to solve it in 2 ways. We subtract their base. The base of the first one, which is what? X is power of 2, right? Y is power of what? 3. Subtract from the base of the second one, which is what? X. You know that this is raised to an invisible power of 1 by law of indices. Because any number is raised to an invisible power of what? 1. Now the second one will have what? Y squared. Now for us, let's subtract the base, and we'll have what? 2. Our x raised to the power of 2. See, they have another x here. We have another x here. By the law of indices, we subtract their power, right? So we're going to have x to the power of 2. X to the power of 2 minus what? This is power 1. So this x is raised to power 1. Then we have what? Y. The first y is raised to the power of what? 3. Then the second y is raised to the power of what? 2. Subtract minus what? 2. At this point in time, we're going to have 2 raised x raised to the power of this is what? This is going to give us x. Y. We have y here. 3 minus 2 is what? 1. So this is 1, this is 1. And by law of indices, anything that's power of 1 is same as that variable, right? Which is x and what? Y. This is our final answer on how to solve this kind of question. I can use another example to solve this guy so I can also understand it in a way that is well explanatory. Now let me use another example to solve this guy. We have 8x to the power of 2, y to the power of 3, all over what? 4x, y to the power of 2. Now for you to explain this guy, you know that this guy is the same thing as what? 8. Look at 8. You can use 2, right? Raised to the power of 3. We still give us what? 8. Now, we have here what? X is power of 2, y is power of 3. All over. Look at 4. 4, you know that 2 raised to the power of 2, we still give us what? 4, right? Then multiply by the power of what? X and y squared. Now, if you look at this guy, what we're going to do now is like, this is becoming what? They are having the power now is going to multiply the power, right? By power rule. So we're going to have 2, 3, this power 3 multiplied by this guy is going to give us what? 3x was square, y was cube. All over, we come to this that side. 2x multiplied by this guy is going to give us what? We have the power base 2, right? The power multiplied this guy is going to be what? 2x, y is power of 2. But you know that this x is just power to this power of 1. Now by the law of what? Division of indices, we take only one of the base, right? And then we subtract their power together, right? So we're going to have, since they have the same base of 2, this is going to be what? 2. Now we subtract their power, this is what? The first one is what? 3x squared y cubed. Then subtract from the power of the down one. This is what? Minus 2x, this is power of 1 here, y is power of 2. At this point in time, we are going to what? Correct items and subtract their power. Now, what we are going to do now, we know that this is going to be what? Equals to 2. Now, if you look at this, is contained by a power of x, I mean. So we are going to have 3. Sorry, let me use the other side of the block. Now, from this guy, we are having what? Our base is 2, right? Now, we are correcting items. This is what? Let's correct in terms of x first, which is what? 3x squared. 3x what? Squared. Then, we subtract from the term of x, which is what? Minus x to the power of 1. Now, we are done with what? Terms of what? X. Now, we come to what? Y. But you know that our y was multiplying what? The terms, right? Y is power of 3 minus y is power of what? 2. Now we're going to have what? 2 is power of what? 3. 3 minus 2y, this is 2y rather. 2x. 3 minus 2 is what? 1, right? 3 minus 2 is 1, right? Now, x squared minus x is what? It's going to give us what? Just what? X. Because you know that 1 times x is what? X. Now we are done with this guy. We are done with this guy. Now, look at this guy now. Y cubed minus what? Y squared. This is going to give us what? Y. So therefore our final answer becomes what? 2xy. Which is the same thing with the second one we solved. So this is how to solve a question using the division law of what? Indices. Now let's look at the sixth law of indices. The sixth law of indices. The sixth law of indices, we have power of what? Of inflation. Power of fraction is the sixth law of indices. Now, if you have a base, let's say what? Fraction x and y. Now we're going to take the cube root. We're going to take the root of what? Y root of what? Y root, because this guy is going to turn to this and become what? Y root of what? The base. And this x is going to be on top of what? The base. This is what? The fractional law of indices. Now for us to apply, let's look at example. Example 1. If you have 4 raised to the power of 1 all over 2. 4 raised to the power of 1 all over 2. But this is fractional law of what? Indices. Which is going to become, the power here is going to turn and become what? The square root of what? 4. These two now come to this side and become what? The square root of what? 4. And there's an invisible power of 1 here. Since this one will stay here, however the answer will come to the root. Now we take root of this guy because 2. It's only 2 we take as a root. But if this guy was 3, this will turn to what? The cube root of what? 4. But since the downside, the denominator is 2, we take what? The square root of what? 4. And then the one will be on top of what? The base. So we are going to have what? Anything that's the power of 1 is what? The same as that number, right? This is square root of what? 4. Now square root of 4 is what? Is equal to what? 2. This has to solve this kind of question using what? The power of a fraction law of indices. Let's look at another example. Example 2. We have 16 raised to the power of 16 raised to the power of 2 all over 4. Now, for us to be able to express this guy, we are going to use that same power rule. This is 4, right? We will have 4th root of what? 16. Then these two now will be on what? The power, the base of what? 16. And we will have what? This tells us that which number that can we multiply by 4 and get what? 16. If you say 2 times 2 times 2 times 2. 2 times 2 is what? 4, right? 4 times 2 is what? 8. 8 times 2 is what? 16. So this is going to give us what? Going to give us what? This implies that the root of what? 4 root 16 is going to give us what? 2. Then we have an invisible power. We have a power here, power of 2. So therefore the answer becomes what? 4. Because 2 raised to the power of 2 is what? Is 4. That is how to solve this kind of question. Now let's call it again. I want you to subscribe to this YouTube channel, and if you have not subscribed, I will be very glad that you subscribe to the channel. Share the video to your colleagues, and if you have any question, you can also drop it on the comment section. Thank you very much. See you in the next section of our tutorial class. God bless you.